In this video, we will be looking at how to represent directions in different ways. The first way is standard position, and it is probably the most familiar one. In this one, we use the horizontal line as our baseline, and we talk about the angle with relation to that horizontal line. So for example, in this diagram here, here's my horizontal, here is my direction. It is 50 degrees above or 50 degrees to the horizontal. So let's do two examples. 120 degrees above the horizontal. I'm going to start off by drawing in my horizontal, and I know a right angle is 90 degrees, so I want to be a little bit more than that. So maybe something like this. That is 120 degrees above the horizontal. The next one is 30 degrees below the horizontal. So again, there's my horizontal, and I'm just estimating here 30 degrees below. And there we are. Now, in grade 11 or in grade 12, something like this, we would talk about it as positive angles and negative angles instead of above and below, because we're using that positive x-axis. Here we're just talking about above or below the horizontal. The next notation is quadrant bearings. And here you are using your typical compass, so north, east, south, and west. And we start our quadrant bearing using the north or south line and then talking about how many degrees towards the east or west we are. So in this example here, we're starting towards the north and we're going 40 degrees in the west direction. So this is north 40 degrees west. Now, it is important that with a quadrant bearing, you always start with your north-south line, which means your angle should always be the angle glued to the north-south, or the y-axis as we typically would call it. So we're going to talk about both of these examples in A, both of those directions, and write them as quadrant bearings. So for this first one here, I know I'm starting at the north, and I'm going towards the east, but I'm not using the 75 degrees because I need this angle here. 90 minus 75 is 15 degrees. So this is going to be starting in the north and going 15 degrees towards the east. And the next one, we are starting from the south and we're going 60 degrees towards the west. So this is south, 60 degrees west. Now let's try drawing. North, 80 degrees west. Well, here's north, here's west. It's close to a right angle, so this must be our direction. Next, south, 25 degrees east. Here's the south. I need to move towards the east, but only 25 degrees in that direction. And there's our quadrant bearing. Our final notation is the true bearing. And with the true bearing, we pretty much redefine our knowledge of the Cartesian grid. What we're going to be using is our north is going to be 0 degrees. And then we just count clockwise. So if north is 0, east will be 90, south will be 180, and west will be 270. So let's start off with a little diagram drawing. We need to draw the true bearing of 95 degrees. Okay, well this here is 0 degrees. This is 90 degrees, and we always want to express it as 3 digits. I need to be a little bit past 90. So here is the 95 degree true bearing. And if we want to convert this as a quadrant bearing as well, we know we're starting towards the south and going towards the east. Now I do need to solve for this angle here, and I know this entire angle should be 180. So 180 minus 95 is 85 degrees. So that means we can write 95 degrees as south, 85 degrees east as well. Let's look at our next one. We have 224 degrees. Well, here's 0, past 90, past 180, west is 270, so we have to be somewhere in between. So maybe something like this. This is 224. Now, for a quadrant bearing, I know I'm starting at the south and going towards the west. I just need to know this angle. So I'm going to do 224, subtract 180, which is 44 degrees, which means our quadrant bearing is south, 44 degrees west. All right, write the direction north 50 degrees west as a true bearing. So I'm going to start off with a diagram. Here's north, here's west. I need to go 50 degrees towards the west. So let's say something like this. Now that is our quadrant bearing, but if I want a true bearing, I have to start from the north and go clockwise. That is my true bearing. I know a full rotation is 360, so I'm just going to do 360 subtract 50 to get a true bearing of 310 degrees. All right, let's go to a couple word problems. We have two scenarios here where we have some quadrant bearings that we have to deal with. So a ship is sailing due east at night. The ship's navigator spots a lighthouse in a direction of north 40 degrees east. After the ship sails 800 meters, the new direction of the lighthouse is north 48 degrees west. How far away is the lighthouse now? So the lighthouse isn't moving, but our ship is. It's going towards the east, but it's in two different locations, one at the start and one 800 meters later in the east direction. So I'm going to start with the first position. So this is where my ship is originally. And the lighthouse is north 40 degrees east of the current ship. So north 40 east might look something like this. And 40 degrees is right here. Then the ship sails 800 meters. So let's say here. And now the ship is at point B. Now the lighthouse hasn't moved, the ship has, and now with relation to its new position, the lighthouse is north 48 degrees to the west. And because I read this ahead of time, I knew that the lighthouse had to be in between the start and ending position of the ship because one was northeast, the other was northwest. And this is the angle here. So the angles we're given are glued to the north-south line. So I need to do a little quick math to get the angles inside my triangle. Because I know this is the east line, it's perpendicular to north. So these two angles here have to add up to 90, which means this angle here is 90 minus 40, so 50 degrees. And this one here is 90 minus 48, which is 42. And now I can solve for the third angle up at the top at the lighthouse, a quick 180 rule. So 180 minus 50 minus 42, and you get 88 degrees. This now gives me a full pair between the lighthouse angle and that 800 meters. Now our goal here was to find how far away the lighthouse is now, which means we want this distance here. I'll just label it lowercase a because it's across from angle A, which means I can use this as my other pair. So I have the perfect sine law set up here. So 800 over sine 88 equals a over sine 50. We're going to cross multiply, and we're just solving for a side, so no sine inverse here. Just going to be dividing out what we don't need, and we don't need sine 88. So we'll do that to both sides, and we're going to round to the nearest tenth. So when we punch in 800 times sine 50 divided by sine 88, we get approximately 693.2 meters. And now we can just write our therefore statement. Therefore, the ship is now 693.2 meters away from the lighthouse. All right, next example. You walk 100 meters due east, then walk north 70 degrees east for 60 meters. How far are you from your starting position and at what quadrant bearing? Round your length to the nearest tenth and the angle to the nearest degree. Okay, so I'm starting here and I'm going towards the east 100 meters. Then I change directions. So when I change directions, I'm going to draw a little compass, and I'm going north 70 degrees towards the east for 60 meters. That's where I end up. And we want to know from start to end, what is the distance? I'll just label D for distance, and at what quadrant bearing. So I'm going to put a little compass at the start to see what my quadrant bearing is from the start to the end position. And ultimately, this is the angle I'm going to need. All right, but first things first, we need to find the distance. With what I have two sides, and I almost have the contained angle. I know this is a 90-degree angle, so 90 plus 70 must be 160. So now we have the two sides, the contained angle. This is perfect for a cosine law. So our distance squared equals, or, since we know that we're going to square root both sides, we can just say the distance equals the square root of, just get that out of the way right away. Our two contained sides squared minus double those two sides times cos of their contained angle. So we'll punch that into our calculator, and we get 157.7 meters, which I will go in and label. And now we have the distance, great. This also opens up a nice full pair for us between the 160 and the 157.7. And if I need that angle theta, I can't find that right away, but I'm going to start off by solving for this angle here. I'll just label it x, because if I know that, then I can get theta really quickly. And now I can use a sine law. So 60 over sine x equals the 157.7 over sine 160. And again, I will cross multiply here. Because I know my end goal is to solve for an angle, I know that I will take the sine inverse at some point. So here all I can cancel out or divide out is the 157.7. So I'll do that to both sides. And then I'm going to take the sine inverse of this entire fraction. And we get approximately 7 degrees. So if x is 7, theta over here must be 90 minus 7, which is 83, which is the bearing north, 83 degrees to the east. So therefore, you are 157.7 meters away from the start. And compared to the start, you are a bear of north 83 degrees east, again from the start. And that's it for the different ways you can represent your directions.